This video is going to explain how to install JMRI on a Raspberry Pi for computer control of a model railway. JMRI is short for Java Model Railroad Interface. It's open source software which can run on a variety of different hardware. It uses American terms compared to the UK where I live. So it refers to model railroad instead of model railway and turnouts instead of points or switches. But other than some different names, it's universal, and it has good support for different operating systems used internationally. I'll be using MERG CBUS based modules. So the first part of this video will apply whatever controllers you're using for your model railway. But some of the later parts will include some aspects which are specific to CBUS. These are all based on CBUS kits from MERG, the Model Electronics Railway Group, available from their kitlocker for members. I'm going to briefly cover what JMRI is, how to install it on a Raspberry Pi, including the Java JRE setup step, adding a DCC controller. And whilst I'm using a DCC controller from CBUS module, the process will be very similar for other controllers. Then going to go into a bit of detail about how CBUS works, in particular the concept of producer and consumer, and a brief mention about the SLIM and FLiM setup options. I'll add a solenoid based point motor, which will be configured using the MMC-SERVER, and I'll show how a servo and a switch can be added, which includes a botched firmware upgrade and how I needed to reprogram the corrupt PIC. I'll then give some thoughts about what I'm looking to do in the future. Note, I won't be going into details about setting up panels or automation at this stage, just how to add these initial devices into JMRI. So I'm not an expert on JMRI. I created this video because I initially found it difficult to set up, and I found much of the instructions hard to find, out of date, or specific to needing to use Windows for some of the configuration. I was eventually able to get it working using just a Raspberry Pi running Linux with the Raspberry Pi OS, but I've only added the devices. I haven't yet performed a full configuration of the layout. Hopefully this will be useful for someone wanting to get started. I'll go through some of the steps that I took in getting this set up, including adding a locomotive, solenoid point motors, servos and switch inputs. So what is JMRI? It's Java-based software that can control DCC locomotives through the throttle application and control accessories such as turnouts, also known as switches or points, signals and lights. It can also be used for layout control and automation, including designing panels, simple automation, scripting through Jython, which is a Python interpreter in Java, and an API. There is support for a variety of different model railway hardware platforms, including the MERG CBUS, which is what I'm using. I'm using a Raspberry Pi 400, which is based on a Raspberry Pi 4. The minimum would be a Raspberry Pi 3 Model B, but a Raspberry Pi 4 or 5 would be better. You'll also need an interface that can connect to the model railway controllers. In my case, a MERG CAN USB 4, which provides a means to connect a computer, including the Raspberry Pi, to CBUS, and then onto the DCC controller and various accessory boards. I'm starting with a new Raspberry Pi OS install. First, I'll perform an upgrade of the OS using sudo apt-get update and then sudo apt-get upgrade. JMRI uses Java, so it needs a Java runtime environment, or JRE. That can be installed using sudo apt install openjdk-17-JRE. JMRI can then be downloaded from the website. It's a tar archive file which can be extracted to the user's home directory using tar-xvzf followed by the file name. There is a script which can set up shortcuts to the desktop. To set that up, change the directory and run create jmri apps.sh with the -- desktop option. I've already made another video that goes into more details about the MERG CBUS DCC controller circuit and the CAB2 handset. They're based on kits which need to be soldered together and are only available to MERG members. However, the cost of membership is reasonable and the price of the kits are much less than many commercial alternatives. The DCC controller is fairly easy to solder, but the handset was much more difficult. My other video goes into more details about that. If you don't want to solder, then I believe that Sprog also provides some boards which also use CBUS, or you can get other commercial DCC controllers which are compatible with JMRI. But back to the MERG modules. The CAN 4 module needs to be connected to the Raspberry Pi and then to the DCC controller via CBUS. We can then add all those to the JMRI configuration. We can now launch Panel Pro, which allows you to choose a controller. In this case, the MERG USB controller, and choose the USB interface. This may differ if you have any other USB serial devices, and you should also be aware that if you disconnect and reconnect the USB, this may be assigned to a different number. However, assuming it's the only USB serial device connected when the Raspberry Pi is powered up, it should keep the same value. We can now launch the roster, which is the list of locomotives, and you'll see that there are none assigned. So let's add a locomotive. Note that JMRI can be used to assign the DCC locomotive number. In this case, I've already assigned an ID based on the running number of the locomotive, which is 5190, and that was programmed directly onto the locomotive. So enter the details, and you can then control using the throttle application. Speed and direction can be controlled on the left, and the function buttons, used for the sounds and lights, etc., are available on the right. So far, we've set up DCC controller, and we can now use JMRI to control our locos. But I've left it until now to really talk about CBUS. The reason being is that for the DCC controller, you don't really need to know much about the setup. You do need to wire it up correctly and add some terminating resistors, but that's all been covered in my previous video, and it's explained with some of the kits. But now we need to get some more understanding of what CBUS is. So CBUS is based around CANBUS, which is a data bus technology designed for use in cars and other vehicles. It provides a way to reduce the amount of wiring in your car, whilst ensuring the connections are reliable and that critical messages can be sent without delay. CBUS essentially takes the CANBUS and adds some protocols specific for controlling model railways in what's known as a layout control bus. There's also further development which is known as VLCB, or Versatile Layout Control Bus. It's essentially the same as CBUS but with extra flexibility for future expansion. It can fully interoperate with CBUS, and I'll be referring to CBUS in this, but it's just as relevant for VLCB as well. As with all bus technologies, there needs to be a way to knowing what to do with the messages and whether they are intended for each device. In CBUS, this can be achieved using two methods. The first is producer and consumer model, where each producer creates an event and consumers listen for those events. This allows consumer devices to learn the events they want to respond to. The other is address mode, where each module or node needs to be configured with a node number, and then each event it raises needs an event number. These can be configured in short address mode, where it's just the event number used to identify the events, or long address mode, where the combination of node number and event number are used. There are then two ways to configure devices. SLIM is the Simplified Layout Implementation Model, and FLiM is the Full Layout Implementation Model. The main thing is that SLIM allows devices to learn events by putting them into a learn mode, and then sending the events for it to respond to. This is usually done by using DIL switches on the PCB, as shown here. Whereas for FLiM, a computer is needed to configure the devices, although the computer is only needed during the configuration. After that, they can, if you prefer, work autonomously. Not all devices support SLIM, and the cab handsets are pre-configured as SLIM producers without needing further configuration, but they can still be used with other devices configured with FLiM. FLiM and SLIM can work side by side. The configuring some devices using SLIM, but others with FLiM. And some FLiM-only devices still appear in SLIM mode when first powered on. This appears to be related to standardized firmware. It's typically just a press of a button to switch to FLiM mode. Also note that while SLIM is producer-consumer mode, FLiM can use either producer-consumer or the address mode. I'll be using FLiM to configure the solenoid point motors and the servos. The technical bulletins for the modules refer to using the FLiM configuration utility to configure the devices, but that application is Windows only. There are two alternatives that work on the Raspberry Pi. One option is to use JMRI, as the CBUS menu includes a CBUS node manager, but instead I used MMC-SERVER, which is written in Node.JS and available across multiple platforms. To install the MMC-SERVER, you first need to install Node.js and the NPM, the Node.js package manager. As Node.js is a dependency for NPM, you can do this all in one go using sudo apt install npm, and that'll pull in all the prerequisites. You can then download the MMC-SERVER from GitHub. You can perform a git clone or download as a zip file and then unzip that. If you unzip the files, then you should rename the directory from mmc-server-main to just mm-server. If you don't, it'll likely still work, but the configuration files are stored in mmc-server, so you'll end up with two directories instead of one. You can then run npm install, which will complete the setup, and then npm start. You'll notice that the Node.js application runs and then opens a web browser, which is how you interact with the application. Note that only one application can communicate with CANVSERVO module at a time, so you need to make sure that JMRI has been closed down. And the same, you need to close MMC-SERVER before launching JMRI. You first need to create a name of a layout. I'll call this test layout. Usually you don't need to configure the interface, as it will detect the first CBUS USB module or similar and connect straight to the CBUS. The screen will show any devices that are on the bus and whether they are configured for SLIM or FLiM. Connecting the solenoid module and then holding down the FLiM button on the device will prompt to add a node number for that device. This will form part of the long address for creating events, so it needs to be something unique. I used 300 for the first device. There are node variables which are configured at the node level. In the case of the solenoid, this allows you to specify the number in milliseconds that the voltage will be applied to the solenoid. These default to 50 milliseconds, which can be adjusted, but do not set these to 0 if the solenoid expects a pulsed output, as that can result in a burnt out motor. Events are then added using the event view. Then events can be added using either the short number, particularly useful if you'd like to be able to control the solenoids using a handset, or a large number, which relates to the node and event number. This can be the originating device or the address of this device if using the address mode. The events have two event variables. The first is which solenoid pair to trigger, and the second is the event mask, which can be used to change how the signals are received. This is a bitmap that reverses the pair relative to the on or off opcode. I've shared the table here for reference if needed. To add the events to JMRI, you need to know the node number for long addressing and the event number. These can be added to the appropriate table. For example, for a point, you would add it to the turnout table, using the American terminology, and there are also tables for signals, etc. If If you're using short addressing, you can just add plus character followed by the event number. Or to negate the value, just prefix with a subtraction symbol instead of the plus symbol. If you're using the long addressing, then you put the node number followed by an E and then the event number. The next module I'm going to add is known as the CANVSERVO kit. This kit is different in that it is both a producer and a consumer. I did have a bit of an issue in that it didn't work the way I wanted it to, and it needed a firmware upgrade to do that. This also provided an opportunity to upgrade this to VLCB. However, it didn't go quite so smoothly. I'll talk about that shortly, but for now I'll show how I added it using the standard CANVSERVO firmware. The kit is based on a universal PCB, which can be used for a variety of different configurations. If you follow the default instructions, then it provides 8 pins for servos, numbered 1 to 8, and shown in the bottom right hand corner of this photo, with one servo plugged in to number 1. And then 8 pins as inputs, numbered 9 to 16, which are in the area above that and shown by the pluggable terminal block where you can screw the appropriate connections in. The servos are listed as an option when creating the event variable, but it doesn't show you details for the switches or the inputs. You could dig through the various documents, but I found one way to see what signals are generated is just to trigger each of the inputs in turn. You'll find that these produce an event which aligns with the input number. These inputs produce an on event when the switch is closed and an off event when it's open. That is reasonable for some setups, but I wanted to have the switch emit a single event just when the button is pressed and not when it is released. It involved a lot of head scratching and reading documentation before I realised that this needs an updated firmware to use the universal firmware, which adds the additional functionality, although at the expense of making the configuration a bit more involved. So using the universal firmware allows the inputs to be configured for toggle switches rather than the standard on-off. I'll go through the same steps as I did when setting up the Solenoid, but using a new Node ID. Note this doesn't support SLIM as there's no switches to enter learn mode. However, the firmware still goes into SLIM mode until the FLiM button is pressed and held in until the green LED goes off. You only need to put it into FLiM mode once and then it'll remember that for future. When I add events, then you can see that configuration is aware that some of the pins are servos and produces the option to choose different actions related to the servos. One thing to be aware of is that by default the stop and start positions of the servo are the same, both set to the midpoint. So it may first appear that these aren't actually working. You'll need to go into the node variables to set the start and end positions of the server to different positions. I have successfully upgraded the firmware eventually, but due to problems I'm not going to go and try and show it here. I did successfully reinstall the original firmware, which worked fine, and then tried the universal firmware, which failed, and then managed to successfully install a slightly older version of the universal firmware. I did think I'd effectively bricked the pick at one point. However, I went to the MERG forums for help, and their advice pointed me in the right direction. I've also had somebody from MERG offer to reflash the pick for me. But instead, I needed to use a Windows laptop with the FLiM configuration utility. But it was able to install a slightly older version of the firmware and get up and running. But it shows how helpful other MERG members can be through the forum. So here are a few points. First, disconnect or power off all the other nodes to reduce the risk of corruption to this and other modules. Download the universal firmware, which is for the PIC 18F26K80. Note that this is 26 rather than 27. Download and unzip the file, then it can be installed through the advanced option on that node. When I tried it, then it said that it was the wrong CPU type, as it detected the PIC as a PIC 18F25K80. However, the 26 is correct, and I had to override that. You should then download and, pressing the FLiM button, put it back into FLiM mode to resume the configuration. When it failed, then I instead connected the Windows laptop with the FLiM configuration utility, and that has the option to program a blank node, which worked. I'm not aware of that functionality in the alternative software that runs on Linux, such as the MMC-SERVER. After upgrading the firmware, the number of different configuration options has increased significantly. This adds additional configuration options for VLCB, and the node variables now provide a lot of configuration options for setting the ports individually. This includes the toggle input option, which is the one I was wanting. The event variables are also increased significantly, allowing a lot of control. The negative side is that with so many choices, this could make configuration harder, and the number of options is overwhelming. So, unless you have a need for the additional flexibility, it may be better to stick with the standard firmware. So, what are my plans going forward? I'm not sure at the moment. I may not even use JMRI. At the very least, it has provided me a way to get the model railway up and running, but I'm considering a few different things. The main thing is I want to be able to interact with the railway through my own code. One is to fully configure and use JMRI for the model railway control. There are options for automation within JMRI, including using Jython, which is a Java interpreter for Python. An alternative is to use JMRI, but to use the API as a way of using my own code to interact with the devices in JMRI. Or I could implement something else directly, perhaps writing directly in Python and creating libraries to interact with the CANVSERVO directly. I'm going to consider my options and provide an update in due course. Thanks for watching. If you haven't already subscribed, please do so now. Click the notification icon to get notified about my future videos. Also, please leave a comment if you have any suggestions about the use of JMRI or libraries for interaction directly with the CANVSERVO. I look forward to seeing you on a future video.